Welcome to today's lesson. In this lesson, we are going to look at a question in linear programming that involves minimization of costs. Let us go through the question. Emma has at least 3,600 beads and plans to make bangles and necklaces. She must abide by the following conditions. 1. A bangle requires 20 beads and a necklace requires 40. 2. For every 4 bangles and 3 necklaces made, the number of beads used should not exceed 480. Number 3. The number of necklaces should be at least twice the number of bangles. Our question reads, if the production cost of a bangle is $5 and that of a necklace is $7, find the number of bangles and necklaces required to minimize the cost. To answer this question, we need 3 very important things. The first very important thing that we need is to know what are our variables for this question. And if we read through the question, we can be able to see that it asks us to find the number of bangles and necklaces that are required to minimize the cost. Therefore, our variables simply become, the first one is bangles, and we say let our bangles be represented by letter X, and the second of our variables is necklaces, and we say let our necklaces be represented by letter Y. The second most important thing that we need to know is what we are going to call as our objective function. Objective function is also called money function. So the easiest way to look at it is where are we going to either minimize costs or maximize profit. In this question, we are looking at minimization of costs. Therefore, we can simply write our objective function by looking at the question again. So this question tells us that the production cost of a bangle is $5 and that of a necklace is $7. Now from that, we can now simply write our objective function as 5x plus 7y equals to a certain constant that we shall be able to generate later. Now the third most important thing that we also need to record before we start answering this question is that we must be able to know something about constraints. Constraints are restrictions. Now, sometimes these restrictions can be so many that to organize that data can be tasking. So the best way to write our constraints down is to be able to create a simple table like what I have done here, where X represents bangles and Y represents necklaces. And then on the left hand side of the table, we identify what constraints are we dealing with. For example, in this question, we are seeing that a bangle requires 20 beads and a necklace requires 40 beads. So we can be able to simply identify that constraint number 1 as what are the requirements. We require 20 bangles and 40 necklaces, but all of these bangles and necklaces should utilize at least 3,600 beads. So it means it is exactly 3,600 beads or more than 3,600 beads, and that now gives us the inequality greater than or equal to 3,600. The second constraint that we are able to see from this question is that for every 4 bangles and 3 necklaces that are made, so here the constraint that we are going to write is simply make. You can use your own words so that you can be able to identify each constraint. So the number of bangles and constraint and necklaces made, those should not exceed 480. So at this point I will come down and write these are 4 and these ones are 3. They should not exceed, so our inequality now becomes less than or equal to 480. Now, our last constraint that we can be able to get from this question tells us that the number of necklaces should be at least twice the number of bangles. So here I am compelled to write something about number. You should be able to see that the first two constraints are connecting bangles and necklaces, but in the last one we are going to see that the constraint is speaking individually about necklaces and individually about bangles. So we can come down and write it as y is less than or equal to 2x. And because it is speaking individually about bangles and individually about necklaces, we are now not going to write x is greater than 0 and y is greater than or equal to 0. So we are not going to write those two, but instead we are just simply going to have these three as our constraints. Now, once we have our constraints in place, just like we have been able to see, then we can be able to generate our inequalities. So we can be able to generate three inequalities from those constraints, and our three inequalities are the first one, 20x plus 40y, giving us greater than 3,600. This we can be able to simplify by dividing on both sides of the equation by 10, and we get 2x plus 4y, giving us 360. Further, we can still simplify this by dividing it by 2, like we are seeing. So our inequality that is now simplified becomes x plus 2y is greater than or equal to 180. That is our first of inequalities. Our second of inequalities is simply 4x plus 3y is less than or equal to 100 is less than or equal to 480. That is a simplified expression. The third one is y is less than or equal to 2x. So these are our inequalities. Now we shall use this inequality, this first inequality, to try and draw a line that so that we can be able to remind ourselves on how we can be able to write down inequalities. So for that, we can be able to draw a graph on inequalities. So we can start by saying that our inequality is x plus 2y is greater than or equal to 180. So from here now, we can be able to draw a simple table that will help us to generate coordinates that we are going to plot. So we can be able to use the intercepts method, or we can just use random numbers and generate numbers that we could be able to use. So in this case we say let x be 100. So if this x is 100, what is y? We are going to see that y is simply 40. And if we are using the intercepts method, then we can be able to ask ourselves, what if x is 0? What is y here? Y is simply 90. Again, what if y is 0? If y is 0, then we are going to see that the whole of this expression shall be 0, so x is 180. So the plots that we are going to put on our graph are for the coordinates 100, 40, 0, 90, and 180, 0. So these are the coordinates that we shall be able to plot. Remember, which type of line again are we going to draw? When we have these signs, greater than or equal to, less than or equal to, we are going to draw a continuous line. If we have this sign, less than and greater than, then we are going to use a dashed line or a continuous line. but in this case our line shall be blocked or continuous. So if we are going to look at our graph, which is next, where are we going to shade? So for us to be able to know where we are going to shade, then we shall be able to identify one test point and use it while shading. So we can either shade above this line or below this line. But because I have got 0, 0 below this line, then I will use this 0, 0 as my test point. So I use it as 0, 0. So I take this 0, 0 and place it into the inequality of the line that I have already drawn. So the inequality of that line was x plus 2y is greater than or equal to 180. So I take these 0, zeros and I place x plus 2 times 0 is greater than 180. If we add the 2, we see that we have 0 is greater than 180. So 0 is greater than 180. This is false. This is false. So I shade on the side that is false. Like now, after drawing our lines, then we can be able to identify them. This red one is y equals to 2x. This yellow one that is here that we have drawn initially is x plus 2y equals to 180, and this green one that is here is 4x plus 3y equals to 480. After drawing these lines, we remember that the line itself represents an inequality, so we use the equal sign. We don't use the inequality sign. The inequality sign is on the type of line that is drawn. Now after drawing these lines, then we can be able to use the corner method to utilize. So we come into the feasible region. This region that is not shaded is the feasible region, or it is also called the bounded region. So in the bounded region, we get the corners. So we shall be able to use the coordinates of these corners to be able to come up with the minimum cost. So to answer the question on finding the number of bangles and necklaces that are required to minimize the cost, then again we can still come up with a table, and here we come up with bangles, which is represented by letter X, and here we shall come up with necklaces, which we used letter Y to represent it. And then at this point we shall come up with the minimum cost. In this case, that minimum cost we represented by letter C using our objective function. And at this point I put down my coordinates. So my first coordinate was 48, 96. And if we are going to use it in this equation, then we are going to say that we have 48 times 5, and then under necklaces we have got 96 times 7, and if we do the math properly, this plus this, the total is 912. And the last coordinate that we have is 84, 48. And with this coordinate, again, if we are going to multiply it in the objective function, we have 84 times 5 plus 48 times 7, and the total that we get is 756. And now we ask ourselves, which is the minimum among all of these three? And we are going to see that our minimum cost is here. Therefore, we can be able to answer and say that the number of bangles and necklaces required to have the minimum cost is 36 bangles from the minimum cost and 72 necklaces